Good evening, everybody. So, once again, I'm sorry for not being in class today. As I said, my daughter's sick, so I'm going to make this flip lesson real quick, or we'll see how quick it goes. But I'm going to do the flip lesson, and then again, these will not be these problems will not be on your final, but they are included in your final project, your quadratic project. So you do need to be able to show me the 5-point graphing method. So if this is confusing to you, we can find some time to meet, next week or during finals week before you do your final project. Okay, so the first thing we're going to start with, we're just going to take a look at some graphs and look at the graphs and know some things about each graph and be able to make some predictions. So the first thing we're going to talk about here is we're going to take a look at the linear equation right here. So we see a graph right here, which we've been graphing these for quite a while, linear equations. And so those, when we talk about those types of graphs, we're basically talking about graphs that have to do with y equals mx plus b. And it's kind of hard to find the slope of this because I didn't make a graph real accurate because I don't really care if it's real accurate. The only thing that I really care about for this is the B. So if we remember what the B stands for, the B stands for beginning. It's where we start our graph. And it also is the y-intercept. And so the y-intercept is right there. That's my B, that point right there. So while I'm not sure what the slope is, I do know that the B is equal to -4. Okay, so that's important. So remember the y equals mx plus b. The constant that's added at the end of my equation is where my line crosses my y-axis. Okay, so now we take a look at the blue graph. Okay, so now we're taking a look at this blue graph right here. And this obviously is not a linear equation, but instead this is a parabola. And so if it's a parabola, then what we know about this equation is it's going to be y equals and x squared, because that's how we make a parabola, is we have to have x squared. Now, there may be some additional things beyond the x squared, so some additional terms beyond the x squared, but I know for sure it's going to be y equals x squared. And since it's going up like this, I know that the x squared is going to be positive. So for emphasis, I just put a plus there to let you know that I know it's going to be a positive. Now, there is one other thing that I know just by looking at this graph. So I know it's a positive x squared because this parabola is going up. And similarly, how I found the y-intercept on the y equals mx plus b linear equation, I can do the same thing here with this blue graph. So I know for sure that it's going to be +5 at the end. And then what's in the middle there is what I don't know, and so we say that's bx, because I don't know what the middle term is. But I know for sure that the end is going to be +5. Just like I didn't know what the mx was, in here I don't know what the bx is. So there's a middle term in here of something, I'm not sure what it is, but I do know that it's going to be +5 at the end. And then now if I look at the red graph, that's this one here, I'd tell some things that I know about it, and what I know about this graph is that it's going to be y equals, and now this one is going upside down, or it's a negative, so I'm say a negative x squared. And similarly, like I knew on this graph right here and this graph here, I knew that this point was my y-intercept. I also know that that is going to be my y-intercept, and that also is going to be at the very end. So that is +2. And then I know there's a term in between. I'm not sure what it is, but it's going to be bx. So just by looking at this, I don't care that we don't know what this middle term is. What I do care is by looking at this graph, you know it's going to be a positive x squared, and it's going to cross at +5. For this one, I want you to know it's a negative x squared, and it's crossing at +2. So I know it's going to be +2 at the end, and I know this one's going to be +5 at the end. And we'll figure out what the bx is here in the middle. Okay, so that's real quick. Just looking at graphs, we should know that. Okay, so now we're going to start looking at the equation and then compare it to a graph. Well, like we just said a moment ago, that this right here, term, this is the A term. The A term tells me what my graph looks like, and it tells me if it's going up or down. Well, since it's x squared, that means it's going to be a parabola. Parabola. And it's going to be a U, or going up. Okay, it's a U. And that's all I know, all of that because of that x squared. And then the other thing that I know is that because of this right here, I know that's going to be where it crosses my y-axis. So this is my y-intercept. So that is where y equals -8, or it's the point 0, -8. So then if I were going to graph this, I'd have my graph like this, and I'm not sure how it goes, but I do know that it's going to go through here, which is -8, whoops, which is -8, it's going to go through that point right there, and I know it's going up. So it's either going to go like this, or it might go like this. But those are the only two ways it can go. It's going to be going through this point right here, and it's either going like this through it, or it's going to be going like this through it. So it doesn't really matter at this point, but I do want you to know that much, that the x squared tells me it's a parabola, and this tells me it's going through that point right there. Okay, so now we're using the same equation, and we're going to try and find out where exactly it's crossing. So we're going to use this thing called zero product property, or for short I call it ZPP. And what the ZPP does is it tells me my x-intercepts. As you saw on the last side, we actually had two possible parabolas it could be that were both going up and going through -8. This process is going to tell us how we find exactly which x-intercepts it is. So it's ZPP. And the key word here is zero. Zero product property. That's what I want you guys to zone in on. The zero product property is when y is equal to 0, because that's what the x-intercepts are. If we think about x-intercepts are when y is equal to 0. So what I'm going to do here is I'm going to say 0 equals x squared plus 2x minus 8. Now I'm using the zero product property because y is equal to 0. Now what I'm going to do for this is we see a quadratic there. The very first thing we should think is, oh sweet, I'm going to do a diamond problem, see what happens. So at this point we should be doing diamond problems pretty well. So it's going to be -8x squared on the top because I multiply the first times the last, and then it's going to be 2x on the bottom. And so then to get the wings, I'm going to multiply negative times the positive to give me my negative top number. So then it's going to be 4x and then minus 2x. So since that works, then I can do the generic rectangle. Remember, I don't do the generic rectangle until after I've done the diamond problem. And then what goes in my first box is x squared, comes from the original. And what goes in my last box is -8. And then my wings are -2x and 4x. So then when I multiply, I get x times x gives me my first box. X times -2 gives me -2x. X times -4 gives me, +4 gives me 4x. And then +4 times -2 gives me -2x. So then my factors are x minus 2 and x plus 4. Now, Notice how I wrote these. Actually, I'm going to erase that last one here real quick. I give myself some more room. And then I have x plus 4. Because what I care about in the zero product property, I'm trying to find when x will make this thing equal to 0. Because that whole thing is equal to 0. So if I say that x equals, or excuse me, 2x minus 2 equals 0, and then I solve for x. So I add 2 to this side and add 2 to this side. So I get x equals 2. So that's going to be one of my x-intercepts. I do the same thing here, and I say equals 0. So then I subtract 4 and subtract 4. So I get x equals -4. So that's one of my x-intercepts. So my x-intercepts are going to be 2, 0, and 4, 0. Excuse me, -4, 0. Okay? Now I'm going to do something that I don't usually do. I usually never write over here. But I want to prove to you that these two numbers make this thing equal 0. So I'm going to plug them in over here. So you probably can keep working down your paper, but I'm out of my slides, so I have to work over here. So I'm going to say, the first one I'm going to do is x equals 2. So I come over here and I say 0 equals 2 squared plus 2 times 2 minus 8. So here I have 2 squared is 4 plus 2 times 2 is 4 minus 8. And you can see that 0 equals 0. Okay, so 4 plus 4 is 8, minus 8 is 0. So it worked. So the other one, or the next one, is going to be 0 equals, and now I'm going to plug in -4. So I have -4 squared plus 2 times -4 minus 8. So -4 squared is positive 16 plus -8 minus 8. So that's 16, and then basically plus a -16, which of course is equal to 0. So what we see there is that when I plug this number in for 0, or in for x, it gives me a 0 right here. When I plug this number in for x, it gives me a 0, and I'm plugging it back into my original equation. Okay, so these are my x-intercepts. What that means is that this parabola is going to cross at these 2 points. And I'll show you that on a graph here in just a second. So for this parabola, I now know it's going to cross at 2, 0 and -4, 0. So over here, what I've done is I've gone ahead and factored it, and I just want us to practice, or to see what it looks like to do the ZPP part. So what I'm going to do then is I split this into 2 problems. I've got x minus 7 equals 0, and I have x plus 1 equals 0. And then I solve both for x. So I add 7 here and add 7 here, and I get x equals 7. So this point would be 7, 0. Notice that the y in the coordinate is always 0. It's always going to be 0 because that's what I'm doing, is replacing 0 for y. And then I come over here and I subtract 1 and subtract 1. So I get x is equal to -1. And so this point is going to be -1, 0. Okay, so that's how you do it. Once you have it factored, that's how you do the ZPP part. Now these bottom two are a little bit trickier because they're not quite so straightforward, but I do it the same way. I'm just going to make this 3x minus 2 is equal to 0, and then 4x plus 1 equals 0. Okay, so I do the exact same thing as I did before. No matter how difficult the problems get, I do the same process over and over again. So here I'm going to add 2 to both sides. So now I get 3x equals 2. And then my last step is to divide by 3. So I get x is equal to 2/3. Now that's kind of a weird x-intercept, but it's fine. You can have decimals or fractions as your x-intercepts. That just means it's not crossing at a lattice point. So this is 2/3, 0 is that point. And so then I'm going to go here and I'm going to subtract 1 from both sides. And I get 4x equals -1. And then I'm going to divide both sides by 4. And I get x equals -1/4. So that point would be -1/4 and 0. So right here are my 2 points for this, for these factors right here. Okay, so I did the same way. 3x minus 2 equals 0, and 4x plus 1 equals 0. And then I just solve for x, and that x value becomes my x, and that x value becomes my x. And then, of course, they're both zeros on that side. Okay? All right, take a look at the next slide. Okay, so now what we have here, I'm going to go ahead and plot it real quick, what we've got so far. So we've got a graph that looks like this. Okay, and I know that my x-intercepts are 2, 0, and -4, 0. I'm actually going to do this in a different color. Sorry if you already followed me in green. 2, 0, and -4, 0. Okay, so I'm going to plot those. So I'm going to say -4, 0 is here. That's -4. And I have 2, 0 over here. That's 2. Notice that I don't really care about the lattice lines right now. I'm just going to be labeling them so it's easier for me to graph my graph. Okay, and then the very first thing that we noticed was that this is going to be going up. This parabola is going up. And then the other thing we noticed was that it's going to be crossing at -8. So then my -8 is going to be right there. So there's my -8. So I now know that this graph is going like this. Okay? Now notice that I didn't come down to this point right here and go up from there, because I know that a parabola is symmetrical. Although mine does not look very symmetrical, parabolas are symmetrical. So what that means is that right through the middle is my vertex. Okay, so my vertex is the lowest point of a parabola, or the highest point of a parabola. If it's a negative parabola, then it would be the highest point. So my vertex is the point that's halfway in between these two, or directly in between these two. So what I can do is I can take the average of my x-intercepts. Okay, so I take the average of my x-intercepts. So to find the average, I do -4 plus 2 divided by 2. And the reason I'm dividing by 2 right here is because I have two numbers that I'm adding together. To find the average of some numbers, you add all the numbers together and you divide by how many numbers you had. So I only have two numbers, so I'm just going to divide by 2. So then -4 plus 2 equals -2 divided by 2. So the x value equals -1. So this is the x value of my vertex. So that means I know that this right here is -1. That's right where it's crossing, is at -1 right there. Okay. Now what I don't know is this y value here. I know that is 8, right there, but I don't know how low it is here. It's a little bit lower, but I don't know how low. So what I'm going to do to find the y value is I'm going to take this number right here, which is my x, and plug it back into my x values up there in my original equation. And then when I solve this equation, that's what my y is going to be equal to. So what I will do then is I will say y is equal to -1 squared plus 2 times -1 minus 8. So that is 1, negative times a negative is a positive, plus -2 minus 8. So that means y is going to be equal to -9. And that makes sense because when I drew my parabola, it's a little bit lower than my -8. So that means my vertex is right here, and that is the point. I'm going to do it in orange or some other color here. -1, -9. That's this vertex right here. So the vertex is -1, -9. Okay, so real quick how I did it is I took the average of my x-intercepts, the average of these two x values. I add them together and divided by 2. That gave me the x value of this vertex. So that -1 is that -1. And I still need to find the y value. I need to know how low this is going. I need to find that y value. So to find this y value, I took my x value and plugged it in. That's the -1 from there. That's the -1 from there. I solved this, and y is equal to -9. So then my point then, my vertex point is -1, -9. Okay, let's take a look at the next step here. Okay, so this is the 5th point, and the 5th point is pretty simple. So now I'm going to draw my graph. Try and draw it pretty well here. Okay, so it goes kind of like that, and I know that my x-intercepts are at -4 and 2. And then I know that my y-intercept was at -8. Okay, so I've got a point here and a point here, and then I got my y-intercept there, and that came from that right there. And then I also just found out that my vertex is the point, the vertex equaled -1, -9. So here's -1, and here's -9. So my vertex is right there. Now, this line here is also called, where this line is here, is also called the line of symmetry. It's also called the line of symmetry. And what that means is that my parabola is going to be symmetrical about this line. So that means that this is the same distance from this, even though in my picture it doesn't look real good, but those two are the same distances. So if we're looking for a 5-point method, I've got 1 point, I've got 2 points, I have 3 points, I have 4 points. The only point I'm missing is this one right here. I do the reflection off of the y-intercept. So I know that if I have a y-intercept that is 1 away on this side, then I have a reflected point over here on this side. So that is going to be my 5th point. And so that would be at -2, and negative 8. So that point is negative 2, negative 8. So now I can draw my line, which is going to go from my vertex out that way, from my vertex out that way. And there are my 5 points. Okay, so the 5 points again are, the first point that we find is the y-intercept. The second and third points we find are my x-intercepts. The fourth point that I find is the vertex, and the last point that I find is the reflected point about the y-intercept. So there's my reflected line of symmetry, and this fifth point is opposite that one. Okay, now what we're going to do is I'm going to do one straight through, just like we would. Okay, so the first thing I'm going to do is my y-intercept is going to be, getting my colors right here. Okay, the y-intercept is going to be right here. So that's going to be the point 0, 5. Okay, so I know for sure I've got the y-intercept at point 0, 5. The next I'm going to find are my x-intercepts. And the way I find my x-intercepts is I'm going to do my diamond problem and generic rectangle. So my x-intercepts are going to be, on top I'm going to have 5x squared, and on the bottom I have 6x, just like we do all our diamond problems. So then my wings are going to be 5x and x. And now I'm going to do my generic rectangle. So in this first box is x squared, the last box is 5. This is 5x, and this is x. So then on the outside I have x times x, then x plus 5, and x plus 1. So then for the x-intercepts, I'm not done yet. Remember that x-intercepts are also z, p, p. So what I do is I say 0 equals x plus 1 times x plus 5. So then I split it into two problems, and I have 0 equals x plus 1, and over here I have x plus 5 equals 0. And then I solve this one, and I subtract 1, and I subtract 1, so I get x is equal to negative 1. Okay, so then this point would be the point negative 1, 0. And then over here, I'm going to, wow, that is terrible. Sorry, people, can't even read my own handwriting. I think that's a 5, right? So I'm going to subtract 5 from this side and subtract 5 from this side. So I get x is equal to negative 5. So then that point is going to be negative 5, 0. So now I have 3 points. I have 5, 0, 5, negative 1, 0, and negative 5, 0. So I'm going to go to a new slide and finish this problem. So the y-intercept is 5, excuse me, no it's not. It is 0, 5, and then my x-intercepts are, what did I say they were? Negative 1, 0, and negative 5, 0. Okay, so now I need to find my vertex. And the vertex is the average. Think vertex is the average. That's how you find the x value of the vertex. That's the average. So that's going to be -1 plus -5 divided by 2. It's always going to be divided by 2 because I always have two x-intercepts. So -1 divided by -5 gives me -6 divided by 2. So the x value is going to be -3. So that's what the x value of the vertex is. Now to find the y value of the vertex, I need to take this point right here and plug it in up there. So I take -3, plug it in there, plug it in -3 there, and then solve. So then I have, I'll just do it right here. So I have y equals -3 squared plus 6 times -3 plus 5. So this is +9, because the negative times a negative is a positive, plus -18 plus 5. So this is -9 plus 5. So then y is equal to -4. So then my vertex then is -3 from here, -4 from there. So that's my vertex. Okay, so the only last thing I need to do is to start graphing them, and then I can find my 5th points. So once again, I'm going to do that over here in this section. I know I never write over there, nor should you. You should keep working down your page, but I'm going to go ahead and do my graph right here. Okay, so there's my x and y axis. And, okay, so I'm going to plot 5, 0. So that is, 0, 5. That is going to be 1, 2, 3, 4, 5. That's my y-intercept. And then I'm going to plot my x-intercepts, which is -1. So that's right there. And -5, 2, 3, 4, 5. That's right there. And then I'm going to plot my vertex, which is down here. So that's -3. So that is 1, 2, 3, and then down 4. 1, 2, 3, 4. So -3, 4 is right there. And what you'll notice is that this is much better than the last one I did. My line of symmetry is right in between. It's right in between. It's, that's a pretty good line of symmetry there for my graph. So then what I know is I know that this point right here has reflected onto the opposite side over there. So there will be a 5th point over here that is at the same height as this point. So that's about right there. So now I can draw my line in, and my line's going to go like this and up, and it's going to go and up. Okay, so those are the 5 points. So the 5 points, once again, are the y-intercept, the 2 x-intercepts, the vertex, and the reflected line about the line of symmetry, reflected point about the line of symmetry. All right, and so the next 2 slides have a couple of problems to do, so let's take a look at them. So here what I want you to do is just practice ZPP. So I've already factored the quadratics for you, and all you have to do is make it equal to 0 and solve for x to fall in the ZPP. And then on the last page, or last one here, here's 2 to try all the way through. Y equals x squared plus 12x plus 32. Go ahead and factor that and find your 5 points. And then do a letter 1, y equals x squared plus 2x minus 35. Again, remember, this is not going to be on your test, but it is part of your quadratic project, which is due during finals week. Okay, have a great Thanksgiving weekend. I hope that everyone is safe, and I will see you guys on Tuesday for a review. I'll also be posting some more review questions for you since I didn't get to post any today. Okay, have a great, safe weekend. I'll see you on Tuesday.